Hi, my name's Jeff, and I'm an instructor at PingCAP. In September of 2023, I led a workshop at the HTAP Summit, and the understanding was that they were going to record all the sessions at the HTAP Summit, so I held off on doing this video. Well, lo and behold, they did not record my session, so I'm doing it again. I hope you enjoy it. With that out of the way, let's get started. So we have a general introduction to TiDB, get certified fast, and that's the key. We want to get you certified fast, and that is how this was designed, to get you certified and fast. That said, it doesn't mean you're not going to know something when you get through with this training. I think we do a good job of introducing TiDB, and you should be able to carry on valid conversations with TiDB people and PingCAP employees once you're done with this. So there is a huge benefit to this training. Let's discuss these benefits and what you'll be able to actually do once completing this. After watching this video, you'll be able to explain the benefits of TiDB Cloud to your friends and coworkers. You'll be able to explain the TiDB architecture to your friends and coworkers, and you'll be able to create a TiDB environment for learning. And you'll be in a great position to earn the TiDB Certified TiDB Practitioner credential. And this is a real certification. You can even post it on LinkedIn. So here are our objectives again. Notice I've added the show everyone your new TiDB Practitioner certification as the last objective, and that's really important. We want you to get certified. All right, we're going to begin our journey with a simple question. What are the TiDB use cases? Okay, so why would you choose to use TiDB? That's a great question. So we have two broad categories here. The one on the left starts with scalable for mission critical workloads. So it's elastic and robust. It's MySQL, which means it's part of the MySQL family, which means you can use MySQL SQL when dealing with TiDB. And it's for massive business growth. So massive business growth is what really separates, excuse me, TiDB from a normal MySQL environment. So you wouldn't want to run your mom's website on TiDB because it's probably going to be really small, unless your mom's running something like Amazon or Databricks or something like that. So we look to the left, we see horizontal scalability, and that's seamless scale in, scale out at the component level. So we can scale storage and compute out separately. Go over to the right a little bit, zero downtime. So it can eliminate both planned and unplanned downtimes by using things like rolling upgrades and high availability. Take a look at the lower left, strong consistency. We're an ACID compliant database, which means we can handle transactional loads at scale, and we do so in a distributed environment. And then the last one on the lower right, it's kind of funny, it's the lower right of the left, is MySQL compatibility. So you can migrate from MySQL ecosystem with ease. You can even use some of the same migration tools and query tools to do this. But the big takeaway is that the MySQL, the SQL dialect that's used by MySQL and TiDB are compatible. They're basically the same. They're the same. We take a look at the right-hand side of the diagram, we see built-in translytical capability. And this is simplified operational and analytical data services. So let's begin. We've already touched upon this, or I made a little side comment on dual engine, row and column. So empower real-time insights from hot and cold business data. So hidden in here is that we have dual storage engines with TiDB. We have a columnar store and a row-based store, and we'll go heavily into these later. Next, we have SQL on big data, and it's the renaissance of SQL to improve data agility. You remember back a few years ago, Hadoop was all the rage, and it was very difficult because it didn't have great support for SQL. TiDB does. Hadoop and other so-called big data systems are also typically very difficult to install, configure, and manage. TiDB, on the other hand, is very easy to install, configure, and manage, so that's another difference. We move down to the left. We have one size fits all again. I'm not quite sure what the intent of this was. Stolen slide. but it encapsulates the complexity and reduces the reinvestment. So what I think this is talking about is that TiDB is very flexible. You can use it for OLTP, you can use it for analytics, you can use it for all sorts of things. And what this says to me is that with TiDB, you get to handle multiple use cases. So one size does fit all. And finally, if we slide over here to the right, we have zero ETL. And what does this do? Well, our slide says it lowers maintenance costs, and that's correct. You don't have to have multiple systems to do multiple workloads. So you don't have to have a system dedicated to do transaction processing and then another system that is there to handle, queries like historical queries. But what's hidden in here is that there's a layer between those two types of systems with ETL, which means a developer has to go in and write code to move data from one system to another so that you can get to both of them. You don't have to do that here. You don't have to do any kind of ETL. If you get back to our dual storage engines, it happens automatically. So we have replication in there that happens automatically. You don't have to do anything, which is nice. So this brings up a great question. What about workloads? We're going to discuss TiDB workloads here. So TiDB and TiDB Cloud. So you'll hear me say TiDB. When I say that, you can just assume TiDB and TiDB Cloud. Supports the following workloads: 24/7 availability with high I/O activity. That's the transactional side. Next, it supports workloads that require sharded or partitioned data that routinely needs new shards. And it also supports them where shards disappear to make it a little more efficient. So what is a shard? A shard is just a way of dividing data so that it sits across servers, or each shard sits on a specific server. Next, we have large database that is growing rapidly. That's important to remember. That's on the test, is large database that is growing rapidly. So you're probably thinking, what does large mean? Well, we'll cover that in a little bit. And finally, database consolidation. Let's say you have 15 to 1,000 different MySQL environments, and you're tired of running and managing the software for all of them because each one has its own set of software. You can take those databases and move them into a single TiDB database, and therefore you only have to manage one database install, and it just makes it a whole lot easier. Okay, so 15 and 1,000, I just threw those numbers out there. They're meaningless. Just as an example, database consolidation is, we probably need to discuss it a little more. So database consolidation means combining multiple MySQL compatible servers into a single TiDB cluster. That's the gist of what it means. You can also think of it as merging multiple sharded database schemas into a single TiDB cluster. That's another way to think about it. What's important though is that this is not a dataling model exercise. This is a lift and shift type of work. So keep that in mind. Okay, let's do something a little different here. Imagine you're sitting looking at your screen, looking at the certification questions, and you see one that asks something along the lines of, hey, do I have to manage all the shards and do I have to do manual sharding with TiDB? The answer is no. All this sharding stuff is happening behind the scenes. You don't have to do anything for it. And that's one of the main differences between TiDB and other MySQL family databases. So keep that in mind. This isn't on the exam, but we just want to point out that TiDB is trusted by global innovation leaders. If you do a Google search, you'll see that Databricks uses TiDB for its infrastructure. You can also go, if you're interested in this, go to that link at the lower right-hand corner of the screen. All right, with that in mind, let's talk about the MySQL family of database. This concept is pretty easy, so don't overcomplicate this. So, what is the MySQL family? You won't hear this stated very often, but we do at PingCAP call this the MySQL family. So to be in the MySQL family, a database must use the MySQL dialect of SQL. That means that the SQL that you use for MySQL is the same as TiDB, TiDB Cloud, Percona Server for MySQL, MariaDB, and one of the variants of Amazon Aurora, that is the MySQL variant. While it's important to have the same SQL, there's another attribute that we must have, and that's the database must be drop-in compatible with MySQL. That means you can substitute one database for another in an application, and the application will continue to run. That makes it very easy to go to TiDB and TiDB Cloud. That's all well and good, but there is more to the story. So if the database is drop-in compatible with MySQL, it means a number of things. One, the SQL variant is the same that your users know, and it's drop-in compatible, which means you can change over, you can alter your application with little muss or fuss. Hidden in here, though, is another aspect. It means that your database administrators who are familiar with MySQL and the tools surrounding it, such as the client and the data transfer tools, they have a leg up, they have an advantage when it comes to learning about TiDB, TiDB Cloud, and other database variants based on MySQL. One thing that this doesn't mean is that the code base for the database is a fork of MySQL. For example, TiDB is definitely not a fork of MySQL. That is not important for something to be a MySQL family member. So important to keep that in mind. And some of this stuff is going to be on the exam, so don't make too much fuss over it. It's pretty common sense, but it is going to be on the exam. Alrighty, so we've talked about MySQL family. Let's begin discussing what makes TiDB different, and we'll do that by discussing TiDB architecture. Our diagram here is reasonably complicated, but we're going to discuss it a piece at a time, so don't worry. The first thing you'll notice that sets TiDB and TiDB Cloud apart from the other databases is that TiDB is built using components. The four colored boxes here show the various components TiDB uses. So let's go ahead and take a look at each one of those components. So we're back to our diagram, and we're going to build our diagram a piece at a time. So TiDB, it begins with a connection. So if you look to the left here, you'll see an application, and that application is using the MySQL protocol to communicate with something. So a user will connect to TiDB as a MySQL application. That's important to remember. Not an Oracle application, not a SQL Server application, not a DB2 application. Users connect to TiDB as a MySQL application, and that's part of being part of the MySQL family. So there's two ways to do this, or there's two categories of users. One is application users, the other is developers and programmers. The box in the middle is application users, and that's where most of us will fall. And actually our DBAs kind of span both of them. But for application users, you usually don't care what you're connecting to, right? You're there to get information, to do queries or whatever. You've got an application that connects. You usually don't care what you're connecting to. Next up, applications that can connect to MySQL can connect to TiDB. That's part of being part of the MySQL family. You can use ODBC, such as Excel, Tableau, and others, and JDBC, Tableau, Looker, others, and APIs. They're MySQL admin tools that use direct APIs. If we move over to the developers and programmers, ODBC, JDBC, and various MySQL connectors, such as Python connectors and things such as that. So it all begins with a connection, and users connect to TiDB as a MySQL application. I know what you're thinking. What are you going to connect to? That's what we're going to discuss next. Okay, this is where it gets a little confusing. So I have up here TiDB runs SQL commands. What I should have up there is TiDB server runs SQL commands. So those TiDB boxes off to the left that are in the TiDB cluster are actually TiDB servers, and that's where our application will connect. So if we go back over to the bullets here, we say TiDB, really server, TiDB server, is the name of the entire system and a component, which leads to confusion. So once again, TiDB server is the component, TiDB cluster or TiDB is the overall system. So have to keep that in mind as you're talking to people. Next up, the MySQL client connects here. We've discussed that. And this component handles SQL requests. It performs SQL parsing, which means it's going to take the SQL that you pass to it, make sure it's valid, correct. It's going to compile it. And then the next bullet points out it's going to generate a distributed SQL execution plan, which is basically telling TiDB how to get the data for the query. Once it does that, it actually returns query results to the MySQL client. It's also stateless, which means if these go down, one of these goes down, the query that's running on that specific TiDB server is lost and has to be rerun, but queries that are running on other TiDB servers continue to run. And finally, this is one of the things that makes TiDB special and gets back to the way we do things with components. It's scalable. You can add or remove TiDB servers. So if your query demands go up, you can add more. If they reduce, you can get rid of some of them. Really great. I'm going to mention it here. We'll talk about this more in a little bit, but TiDB server is the query component, which is compute. We'll talk about the storage component later. And because we use components, you can scale out query, TiDB, or storage independently of one another, which is a big deal and is definitely on the test. Speaking of storage, next we're going to talk about the TiKV server. So the TiKV server provides storage for the TiDB server component. It's row-based data store, and it's used for online transaction processing. That's OLTP data. The data is distributed across multiple nodes, and it maintains multiple replicas. By default, there are 3 replicas of the data stored, and we also support high availability and automatic failover. Now, TiKV can be used without TiDB, but we're not going to talk about that, not on the test. That's a different use case. And surprisingly enough, TiKV, and that is ironic, TiKV stores data in key value pairs. That's where the KV comes from. Speaking of storing data in key value pairs, let's take a look at how that happens. So it's pretty simple how we take relational data and map it to key value pairs. First, we create a key, and the pattern of the key is table prefix, which is a table ID, with an underscore concatenated to a row ID. And this maps the table data to the key value pair. TiKV hosts a vast sorted key value map so that it can keep track of all this data. And when you do your table query, it can go and pull the correct key value for the data that it needs to go get. At the bottom of the slide, we have an example, and these are 3 rows of data from some table where the table number is actually 10. So the first row of data there, you have the first column entry is TiDB, the second column entry is SQL layer, and the third column entry, it just happens to be 10. That has nothing to do with the table. So if we look at the table mapping, we'll see that table 10 is T10 underscore R1 because that's row 1, and then the arrow means that it maps to the value TiDB SQL layer and 10. Let's take a look at the bottom one. So we have PD, we have manager, and the value 30. Once again, the table is table 10, so T10 underscore R3. Remember, this is the third row, and that maps to PD, manager, and 30. Okay, now let's take a little bit of a deep dive into TiKV. We're going to do some review and talk about multi-version concurrency control. So recall that TiKV is the storage layer, and by that we mean TiKV is responsible for making the data in the database permanent. Also, TiDB, the SQL processor, uses the KV API to talk to TiKV. This is important, right? Because we have separation between storage and compute. The TiDB SQL processor represents compute and TiKV represents storage. The next bullet, not all SQL processing is performed by the TiDB component. This is the first time we've mentioned this. This pushdown is handled by the coprocessor. We are able to push down such things as filtering, mapping, count, sum, and other things that can be spread across multiple machines down to the storage layer. What this means is it increases parallelism and actually can help by reducing the amount of data returned to the TiDB server. TiKV also implements ACID capabilities. Now we'll talk about those in a little bit, but that's the ACID capabilities are basically what makes the database able to handle transaction processing at speed. TiKV uses Google's Percolator module and uses optimistic locking for transactions. So that's what we're going to get into next. And that's where multi-version concurrency control comes in. A lot of databases that when they do updates, update the data in place. TiDB doesn't do that. What it does is it uses MVCC to create a new version of the data object instead of updating it in place. So this is a difference between TiDB and other databases. Next bullet is current readers can see older versions while the update transaction runs. And the reason for this is that it creates a copy. It keeps the older copy, uses timestamps so that it knows which is the newest one and which is the older one, and can cycle through the older ones and report back. So it can do all this while update transactions run. And finally, MVCC does not require locking, which means that we can run multiple transactions and they don't stumble upon each other. At this point, you're probably asking yourself, how does TiKV persist data? And isn't that really important? Well, it turns out it is. And if we go down to the next item on our architecture diagram over there on the left, we see RocksDB. RocksDB is a persistent key value store. It is a component used by TiKV. We do not surface RocksDB directly, but we use it indirectly. So RocksDB is a persistent key value store. That means that the data is stored permanently. One of the cool things about it is not only does TiKV use RocksDB, it actually uses two instances of RocksDB. One for the key value pairs, the actual data that we're going to be querying and writing. The other RocksDB instance is used for Raft logs, and we'll talk about them next. So the Raft algorithm is all about storage, so that's where we'll start. And we'll begin by saying that TiKV nodes, these are individual machines running TiKV, and usually in a production environment, or always in a production environment, there'll be more than one of these nodes. And these nodes store data in something that's called a store. So each TiKV node contains one or more stores. And a store is a TiKV process that manages data storage. So we've kept our diagram here reasonably simple. So we have 4 nodes, and each one of them has a store. We have store 1, store 2, store 3, store 4, and they are on the corresponding nodes, TiKV node 1, node 2, node 3, node 4. And the client up at the top is not our MySQL client. It is going to be TiDB server, the SQL processing layer. That is the client for TiKV. So we've talked about stores. Now we're going to talk about regions. And a region is the basic unit of data movement for TiKV. And each region is copied to multiple nodes. So if you look at our diagram, you'll see there are regions all over the place on all 4 of our nodes, on all 4 of our stores. So I have a question for you. How many regions are there on this diagram? Feel free to pause the video while you count. So if you look at this diagram, you'll see a lot of little boxes there. But if you count them, you'll count 5 regions. There's region 1, region 2, region 3, region 4, and region 5. I know what you're thinking. Jeff, there are a lot more than 5 boxes on this diagram. So what's up with that? Well, TiKV replicates data. So we have 5 regions, but 15 different little boxes there. So you can discern by default, TiDB creates 3 replicas of data. So if you take a look at our diagram, using region 4 as an example, we can see region 4 has 3 replicas. One on node 1, one on node 2, and one on node 4. So one of the things that you have to remember, or that you should remember, well, you have to remember it for the exam, is that each replica is at most 96 megabytes. That at most is important. What happens when a replica is much smaller than that? During idle times, TiDB may go through and combine it with another small replica so to reduce the replica count. What happens when a replica goes over 96 megabytes? TiDB will split it so that it's in multiple replicas. Now, 96 and 3 are magic numbers, and you should remember them for the exam. This all leads us to a very important question. How do we keep data in sync? How do we keep it consistent? And remember, I said we were about to discuss Raft, and it's been a long time and we haven't discussed Raft, so it may be that the Raft algorithm is how we do this. At this point in your TiDB journey, you don't need to know a whole lot about the Raft algorithm other than it exists and that it is set up to solve this problem. It keeps all 4 of these replicas in sync so that each one has the same data in it. And the way it does that is via logging and a bunch of stuff that's really beyond what we're going to talk about here. For example, we have courses that talk about Raft for hours. I'm not going to do that to you today. So if I ask the question, or if the test asks the question, so if the exam asks a question similar to how does TiDB ensure that data is consistent across nodes, the answer would be the Raft algorithm. So at this point, we've been discussing storage, and that's how we got into the discussion of Raft. We're going to start back up with storage because TiDB is very unique in that it has 2 different storage engines. TiKV, the one we just talked about, is for transactional processing. We also have a column store, and that's where we're going next. Okay, this slide was our jumping off point. I wonder if there's something important on here. So if you want to pass a test, you may want to remember this. Data is stored in RocksDB, or TiKV, key value pair data is stored in TiKV. There's also another set of data that's stored in TiKV. Remember, there's 2 RocksDB instances in each TiKV node, and the other stores logs. So you'll want to remember that as well. If we look back to our storage cluster, we'll notice a lot of white space in that box. So there's something missing, and I mentioned it a minute ago, and that is a column store. Our column store is called TiFlash, so let's go ahead and add it now. So if we look to the right of our diagram, we see TiFlash server. So it also provides storage for the TiDB component. It's column or data store, and it's used for analytic data. The data, like TiKV, is distributed, and data can be distributed across physical locations as yet. And this last bullet is wrong. It is absolutely open source now. There's some more really cool secrets about TiFlash. The first is, this isn't required. When I create a table in TiDB, I have to explicitly say, create a TiFlash component for it. And that's because many of the tables don't require the analytics side, and we don't want to replicate data and take up extra space. There's an alter table command that you can issue in SQL that will absolutely create the TiFlash replicas for you. And if you do a lot of big queries, you can immediately see that TiFlash most of the time will help performance greatly. That takes care of the storage tier. So let's talk about the brains of this entire operation. What makes it all work together? And that would be the placement driver. And because the environment needs a brain. So we see the placement driver up top there. We see PD, PD, PD. There's 3 of them there. So the PD, or the placement driver cluster, contains the metadata for TiDB cluster for the whole thing. It allocates transaction IDs to distribute transactions. That's what makes this a distributed database. If you recall, when we had the different TiKV nodes displayed in our diagram, the PD cluster, using its transaction IDs, distributes data across those nodes. Next, one PD cluster consists of at least 3 nodes. That at least is important, and it is on the exam. You can have 5 nodes, you can have 10 nodes, 11 nodes, but you must have 3 nodes. And finally, the PD hosts a web server that runs the TiDB dashboard. This is the management UI for TiDB. Next up, let's talk about TiSpark. At some point you're going to laugh, but up top there we have TiSpark in-memory analytics is a must-have. We're going to find out that that's not entirely true. The only reason we're showing this is because you'll see different diagrams and a lot of them have TiSpark on there. So what is TiSpark? TiSpark is basically just Apache Spark running alongside of the database portion of TiDB. So as we can see on the bullet points here, TiSpark Query Library runs Apache Spark SQL on TiKV, which means you can use Spark SQL to query your TiKV data. It integrates with the Spark Catalyst engine, and it supports distributed writes to TiKV. Once again, this is not on the test. You don't have to worry about it, but it is kind of nice to know. Speaking of nice to know, TiSpark is optional on self-hosted, and self-hosted means you've installed the software yourself and you're running it either on your VMs in the cloud or hardware in your data center. And this is me trying to be cute. Actually optional on self-hosted and not available on TiDB Cloud. That is TiDB Dedicated and TiDB Serverless. Neither one of those supports TiSpark. And if you need to know any of this for the test, it's optional on self-hosted and not available from the cloud product. That's TiDB Dedicated and TiDB Serverless. All right, let's move along from something that's not all that important to something that is very important. So we're back to user connection. So a user app connects to TiDB, and we can see that app on the left-hand side of the diagram in blue. It says My App. Recall that the app is going to use the MySQL protocol, and it's going to connect to a TiDB server. We can see 4 of them in the box next to My App. So the question you're probably asking yourself is, which one of those TiDB servers am I going to connect to, and don't they all have different IP addresses? So do I, as a user, have to know the IP address of every TiDB server in my TiDB cluster? And fortunately, the answer to that is no. We'll use a load balancer to make this easier, because the load balancer is going to have a single IP address, and then it's going to route connections to those various TiDB servers. So there is a little nuance here, and this seems like it would be an excellent test question. Our first bullet: self-managed deployments do not include a load balancer. You or I, whoever is going to install this thing, has to install and configure a load balancer for us. Second, TiDB Cloud, serverless and dedicated, includes a load balancer. So let me read that again. TiDB Cloud, serverless and dedicated, includes a load balancer. You don't have to do anything, it just works. If I install my own software, I have to install and configure a load balancer if I need one, and that is on the test. So here's an updated diagram. On the left we see My App, we see an arrow going both ways, connecting to a TiDB server, and now it's running through a load balancer. And the load balancer will choose which TiDB server your app connects to. You don't have to do anything. And it will choose it based in a round robin method, and it depends on how much load is on a TiDB server. But that's how this works. Once again, if you install it, you have to install the load balancer. If you're using TiDB cloud-based products, TiDB Dedicated, TiDB Serverless, PingCAP handles that for you. Next, let's talk about TiDB SQL Processing. So we'll return to our trusty diagram. So what we're talking about is what happens and where. On the left-hand side of the diagram, you can see SQL processing happens here, and that is the TiDB server layer, the TiDB cluster layer there. In order to really talk about SQL processing, though, we need a new diagram, so here it is. This diagram is just a little bit more detailed, but it will make sense to you. Notice that the box in the middle is really just our TiDB server. It's going to be the portion that handles SQL processing. And then off to the right, we have our TiKV server or TiKV cluster, and finally our TiFlash cluster. Once again, we'll start off to the left. This is an application that is connecting to TiDB, and that is using the MySQL client. The client is going to use the MySQL access protocol to communicate with the TiDB server. With all this talk about MySQL, this is a great time to bring up the concept of the MySQL family. And in a nutshell, a user can connect to TiDB and think she is connected to MySQL. That's one of the things that makes TiDB part of the MySQL family, or even creates a MySQL family in the first place, is that there are many different databases that use the same protocols. And that statement, a user can connect to TiDB and think she is connected to MySQL, is very important. So the final little question down there, what are the implications of this? What are the implications of the MySQL family? It's very important. It means that if you're a MySQL user, you can plug and play TiDB into your environment and the application will work. Using a database that's part of the MySQL family gives you a flexibility that you can change out your existing MySQL infrastructure for something like TiDB when your needs grow. If you need distributed processing, TiDB will be there to handle it. Another aspect of this is if you take the time to learn MySQL, it makes the transition to something like TiDB a whole lot easier because the SQL layer is the same, the syntax is the same. You'll hear a lot of discussions about different components in the environments, and they'll be the same, like the client. We use the MySQL client with TiDB, so once you know how to use that, you're all good. One thing we haven't talked about is that there are DBA tools and developer tools that work with MySQL, and they will certainly work with TiDB as well because TiDB is part of the MySQL family of databases. Let's go back to our diagram. So here we see the parser area. We see at top, we see parser, underneath logical optimizer, and finally physical optimizer. So what does this stuff do? Naturally, it parses the SQL and optimizes the query. So the TiDB server actually validates that the SQL sent from the client to TiDB server is valid. That's what parses means. And it optimizes the query. It takes that valid query and figures out how to best satisfy it. And when we say satisfy a query, we mean get the correct answer back to the user as quickly as possible. The next thing TiDB server does is it communicates with our storage layer and accesses TiKV and TiFlash. This may come as a surprise, but it can access both TiKV and TiFlash within a single query. This is very, very powerful, and it leads to really quick queries. It's not on the diagram, but TiDB server can access multiple TiKV nodes and multiple TiFlash nodes from within a single query. It's important to know, as we'll see here in just a second, there is a constraint on the actual TiDB server. Let's move back to the left-hand side of the diagram at the arrow between the client and the protocol layer. Are we missing something here? You have to know the answer is yes, or I wouldn't be showing this. Although TiDB server can connect to multiple TiKV or TiFlash servers, a single client connection can only connect to one TiDB server instance at a time. That's really worth remembering. A single client connection can only connect to one TiDB server instance at a time. And with that, we are finished with the new content. So what we're going to do now is we're going to go through and do a thorough review of what we just learned. This will help you remember things that are important. It'll give me a great chance to point out and say, hey, this is on the test. You should remember it. So without further ado, let's do a thorough review. Okay, question 1. True or false? I must install and configure a load balancer on a dedicated TiDB cloud cluster. So the answer to this is false. Remember, you must install a load balancer, or you can install a load balancer if you install the TiDB, either in your cloud data center using VMs or on-prem. If it's TiDB dedicated or TiDB serverless, PingCAP does it for you. Question 2, this is also true or false. TiKV server stores data in a columnar format. So this one is false. Remember, TiKV stores data in an OLTP type row column values type format. It's used for OLTP. Columnar is used for OLAP or analytics processing. Question 3. TiKV server uses what storage technology to make TiDB data permanent? The answer is RocksDB. Recall that there's 2 instances of RocksDB inside of TiKV. One handles the key value pair store and the other one handles logs. Question 4. Which TiDB component ensures the durability of data? The answer is TiKV server. Remember, TiKV server stores the key value pair, the data that's required by TiDB, the overall environment. And you can't have a TiDB environment without TiKV. On the other hand, TiFlash is the columnar store and it is optional. Question 5. True or false? The TiDB Playground cluster launched by TiUp is adequate for production environments and/or heavy workloads. Okay, this is embarrassing. I had to go back and check this video, and I have not talked about this. I talked about this during the HTAP Summit presentation. So in order to explain this, I am going to bring a video from our YouTube channel. It's less than 3 minutes long, and it explains this adequately. I think it explains it pretty good, but take a look and we'll come back to this video. In this video, we're going to take a look at TiDB Playground. So it begins with the curl command, and we'll issue that, and this is just to show setting up the software, basically to get to that TiUp Playground. So let's type TiUp Playground and then watch what happens. So TiUp is checking for updates and shouldn't take many because we just installed this via the curl command. You can see it's starting PD instances, TiKV instances, TiDB instances, and the message waiting for TiDB instances ready is interesting because it's 127.0.0.1, which means localhost. So the question that we get most often is, can I use this playground? Excuse me. Can I use this playground for production work? And when you start seeing 127.0.0.1 or localhost, you really should understand that no, this is not for production work. Okay, at this point it's up and running. We can see a connection string that we could use to connect from a client to this TiDB instance. We can also see some URLs of the management consoles. So let's go ahead and hit Control-C to stop it, and you'll see that it starts coming down pretty quickly. And then there's some pieces of it that are a little slower to come down because it has to make sure things are copacetic. So we're waiting for some things to quit, and there we are. We're back at our prompt. The key takeaway here is that TiDB Playground is not meant for production or work that has to be permanent, so don't rely on it. Use it for learning and experimentation only. Thank you for watching the video, and please take time to subscribe to the YouTube channel. It would help us a lot. So as we saw during our brief video interlude, the answer to this is false. The TiDB Playground runs on localhost, which is 127.0.0.1, and it is absolutely 100% not adequate for production environments and or heavy workloads. And by production, we mean anything that you depend upon. If you depend upon it, you need to install or get a different type of TiDB. Question 6. True or false? TiFlash is useful for OLTP only workloads. This statement's false. TiFlash is useful for OLAP or online analytics processing workloads. Remember, it's optional. OLTP only workloads would be TiKV, and TiKV is required. Question 7. Briefly explain why you must always have the same number of TiDB servers and TiKV servers. Well, you can't explain it because it isn't true. So in TiDB, compute and storage can be scaled independently. So this is very important. It means that I can, if I need more query services, I can increase the number of TiDB servers. If I don't need as many, I can reduce them. If I need more storage capability, I can increase the number of TiKV servers. And if not, I can reduce TiKV servers as well. So separating of storage and compute is one of the hallmarks of TiDB. Question 8. True or false? TiKV is useful for OLTP only workloads. This is true. TiKV is the key value pair. It's used for transactional data and useful for this type of workload. Question 9. Which ETL tool is recommended for migrating data between TiKV and TiFlash? Well, this is a trick question. ETL isn't required. TiDB handles it all for you. I think I made one sentence on this during this video, and it's worth repeating again. TiKV, the transaction side, TiFlash, the OLAP side, TiDB keeps everything in sync for you. You don't have to do anything. There's no manual migrating data from one to the other. This is one of the capabilities of TiDB that makes it so easy to use. And finally, question 10. True or false? Multiple TiDB server instances can participate in executing a single query. This one is definitely false. Each query is assigned to a single TiDB server, and that TiDB server is responsible for that single query. Don't get confused. We said that a TiDB server can connect to multiple TiKV servers to satisfy a query. We said a TiDB server can connect to multiple TiFlash servers to satisfy a query. And we said that a TiDB server can connect to a combination of multiple TiKV and multiple TiFlash servers to satisfy a query. But the query can only be run on one TiDB server. So right now you're almost ready to get certified. I would suggest that you watch the helper videos in the PingCAP Learning channel. That's where you're seeing this video right now. And once you've done that, then you will be ready to take the certification exam and earn your certificate of recognition. So once you pass the exam, you will be a TiDB practitioner. You'll get to announce this on YouTube, and you do get a real certificate, just like the one that you're seeing there. Signing up for the practitioner's exam is easy. You'll go to pingcap.com/education/certification, and you'll see that upper little icon, the PingCAP Certified TiDB Practitioner, and then you'll click on Start Your Journey to Become a TiDB Expert, and then you will click the Register Now button in order to register for the course. So the first thing you need to do is to look down at the bottom and make sure that the contents mention an exam. So it should mention exam, PingCAP Certified TiDB Practitioner exam information, and there's two other items down there. If you see that, then click the Get the Course button and fill it out and be on your way. I would really appreciate it if you would subscribe to the PingCAP Learning channel on YouTube. You can do that by going to youtube.com/then PingCAP Learning. And once you get to that screen, you can say subscribe, and that way you'll know when new videos have been posted. We're going to do another series like this one on the next certification exam as well, so stay tuned. So on behalf of myself, Jeff, and the rest of the PingCAP Learning crew, I'd like to thank you for watching this video. Hopefully you'll take the next step and watch the helper videos in this YouTube channel, and once you've completed those, go ahead and take the exam. It's free. You can take it as many times as you want to. There's no shame or downside to taking it and failing it. So just give it a go. It's 20 questions and it shouldn't take you very long to do it. So good luck. And if you have any suggestions or comments, please feel free to place them on this video. Once again, thank you for spending your valuable time with me. Goodbye.